objects of study. So there are 2 players, 2 kingdoms. Now, we have a number of troops, and we begin to think of these troops as, an expendable budget of altruistic, soldiers who have been allocated to us. And also a number of a number of castles that have been identified for us. These are key locations we want to defend or attack. Okay, and so first we're going to go over the notation. So we denote N as the total number of castles to explore, and B as the total number of troops available. Moreover, for each k equal to 1, 2, so on and so forth up until n, we denote pk as the number of soldiers placed in castle k by player 1, and qk as the number of soldiers placed in castle k by player 2. Note that P1 plus P2, so on and so forth, plus Pn is equal to our budget of troops B. This means we have to allocate our entire budget of troops to, the castles, and same for player 2. And moreover, for the purposes of this presentation, we'll only focus on n equal to 2, so 2 castles. So really quickly, the rules of the game. A player wins castle K if they have more troops in that castle. The player wins WK points. The goal of the game is to have the total number of points over all castles. This means you've identified some locations for me as well as their value to you. So you've identified that castle 1 is worth W1 points and castle 2 is worth W2 points. How many troops? We have a motivating question. How many troops should player 1 allocate in each castle in order to win the game? Okay, so first let's take a look at our game configuration. Consider the Colonel Blotto game with equal budgets in 2 castles. We have castle 1, castle 2, player 1 with their allocation of P1 at castle 1, player 1 with their allocation of P2 at castle 2, and the same for player 2 with Q1 at castle 1 and Q2 at castle 2. We have the motivating question. What has to happen for player 1 to win? The rules are, once again, if P1 is greater than Q1, then player 1 wins W1 points, and player 2 wins 0 points. If P1 is equal to Q1, then neither player wins any points. And this is the same for castle 2. Okay, so now we'll go over our game possibilities. We've identified that, player 1 can either place more soldiers at castle 1 than player 2, the same number of troops at castle 1, or less troops at castle 1 than player 2. And then now for castle 2, we have that player 1 could place more troops than player 2 at castle 2, the same as player 2, or less than player 2 at castle 2. So let's go over the first case where we have, player 1 allocates the same amount as player 2 in castle 1, as well as they allocate the same amount in castle 2. So we see that player 1 gets 0 points, player 2 gets 0 points. This game possibility ends in a tie. Now we're going to explore that. Now we're going to explore P1 equal to Q1 and P2 greater than Q2. In this scenario, we have that player 1 will get 2 points because they win castle 2. Player 1 gets 0 points because we tied at castle 1. This means that player 1 wins. But you'll notice that this game possibility is highlighted in red because remember our fixed budget of troops. So if we place the same number of troops at castle 1, and we're saying then player 1 goes on to place more troops at castle 2 than player 2, we can never end up in that scenario. So this game possibility we'll never have to worry about. And so now let's move on in our diagram to this square where we've still placed the same amount at castle 1, and we've placed less at castle 2. We see that player 1 gets 0 points because they tied at castle 1, and they went on to lose castle 2, so player 2 gets 2 points, player 2 wins. But for the same reason where we placed the same number of soldiers at castle 1, and we went on to place, player 2 went on to place more soldiers at castle 2, this can't happen because of our fixed budget. Q1 and Q2 need to add up to B. Okay, and so now let's explore this row. So P2 equal to Q2. So we'll start off on the left side and then go on to the right. So P2, so we place the same number of soldiers in castle 2, and we place more soldiers in castle 1 as player 1, right? We see that player 1 gets 1 point because we win castle 1, but we tie at castle 2 since we place the same number of troops. So player 1 wins in this scenario. But for the same reason of the fixed budget, we placed the same number of troops here at castle 2, and yet we went on to place more troops than player 2 at castle 1. This can't be because P1 plus P2 needs to equal B. And so now let's explore this case where we placed the same number of troops at castle 2 between both players. But went on to place player 2 went on to place more in castle 1. We see that player 1 will get 0 points because we tie at castle 2, but we also lost castle 1, so player 2 gets 1 point. And in this scenario, player 2 wins. But once again, for the same budget invalidity reason, we will never see this game scenario. Okay, and so now let's explore this column. We'll start at the top. We're going to look at player 1 places more soldiers at castle 1 than player 2, and they went on to place more soldiers than player 2 at castle 2. We can never end up in that scenario, so you already see that it's highlighted in red. But regardless, in this scenario, player 1 would get 3 points, player 2 would get 0 points, and player 1 would have won. And so now we're going to look at this bottom cell. This is also the scenario where player 1 has placed more at castle 1 than player 2, but player 2 went on to place more at castle 2. This is actually can happen. This is because let me back up here 1 second. So here we see that player 1 has placed more at castle 1 than player 2, and so they win castle 1. Player 1 gets 1 point. This is player 1 places less at castle 2. This is expected since they placed more at castle 1. So player 2 would win castle 2 since they placed more at castle 2. Player 2 gets 2 points. Player 2 wins. This is an expected game scenario in which player 2 wins. Okay, now we're going to go over this column and this scenario for the same reasoning as that one. Let's look at this. Q1. So player 2 places more at castle 1 than player 1. And then player 1 goes on to place more at castle 2. This can happen since player 2 allocated more at castle 1. So we can expect to see that player 1 gets 2 points, player 2 gets 1 point, and player 1 wins in this situation. Okay, so now for the last scenario that cannot happen, we have that player 2 places more at castle 1, and they also somehow have the budget to place more at castle 2. Because of our fixed budget, this cannot happen, but in this scenario, player 1 would have gotten 0 points, player 2 would have gotten 3 points, player 2 would have won. So now we see in red are all of the invalid game states, and in black are all of the valid game states. Our motivating question, if we will remind ourselves, is what has to happen for player 1 to win. And we see that in the case where P1 is less than Q, when we allocate less at castle 1 but more at castle 2, player 1 wins. When we allocate the same to both castles as the other player, we tie. When we allocate less at castle 2 but more at castle 1, we lose. Okay, that's good to know. And so now for our results, we have a proposition that says, we place more at castle 1 than player 1, then player 1 wins W 1 points and player 2 wins W 2 points. Say P1 equals Q1, neither player wins points. Say P1 is less than Q1, then player 1 wins W 2 points and player 2 wins W 1 points. And we, as a result, get this corollary without loss of generality. Say that W1, W2, both non-negative. Then let me reread that. Say that, we have W1 greater than 0, W2 greater than W1. Then player 1 wins if and only if they put more troops in castle 2 than player 2. So that's our strategy. For player 1 to win, place more troops in castle 2. So we have some motivating questions. If we have more than 2 castles, what is the strategy for player 1 to win? And secondly, is there a pattern for an arbitrary number of castles? For my acknowledgments, I'd like to thank Dr. Everett Goins for advising me through the completion of this research. Thank you for listening.